This is day 23 of Advent of Code 2024 Done and Go. This challenge is called LAN Party. As the historians wander around a secure area at Easter Bunny HQ, you come across posters for a LAN party scheduled for today. Maybe you can find it. You connect to a nearby data link port and download a map of the local network, the puzzle input. The network map provides a list of every connection between two computers. For example, KH to TC, QP to QH, and so on. So each link of text in the network map represents a single connection. The line KHTC represents a connection between the computer name KH and the computer name TC. Connections aren't directional. TC-KH would mean exactly the same thing. LAN parties typically involve multiplayer games, so maybe you can locate it by finding groups of connected computers. Start by looking for sets of 3 computers where each computer in the set is connected to one another, 2 computers. In this example, there are 12 such sets of 3 interconnected computers, so like these. If the chief historian is here and he's at the LAN party, it'll be best to know that right away. You're pretty sure his computer's name starts with T, so consider only sets of 3 computers where at least one computer's name starts with T. That narrows the list down to the 7 sets of 3 interconnected computers, like this. So find all the sets of 3 interconnected computers. How many contain at least one computer with a name that starts with T? Okay, so let's get started. This is what this input looks like, but we will switch to this input, and there are 7 for that. So we are wanting to first get the inputs, which are the connections between them, and I guess we can do like connected. And this will be a map. Oh, first we need to do make map, and this will be string, and then this would have a map string for all the devices connected to it, and that would be bool. So we'll do for line in range lines, and see connection exists is equal to connected. Actually, first I need to break it up. So parts is equal to strings dot split, and we're splitting on this. So comp1 is parts 0, and comp2 is parts 1. So I guess we'll do this. So exists 1 comp1, and that should be if then not exists. Then this is equal to make, and it would be this. Now we do the exact same thing for exists 2 with comp2. Comp2 here exists 2 like this. Actually, okay, that's meant to be a string up here for the split. Oh wait, I need a line then split. There we go. And now with this, it would be connected comp1 comp2 equal true, and then we just switch them around. So we're creating a list of all the computers and then all the computers that one's connected to, and then we're just outputting at how many contain at least one computer with a name that starts with T. Okay, so starts with T. Let's do, actually, if we only want ones which start with T, we then skip most of these. No, we still have this. Yeah, we still have all this. Because we need to see the other 2 which aren't T, so that is fine. But we will do T comps, and this will be list of string, and we will do if, nope, this needs to be a map. So I want all the unique computers that have that. So if comp1, I'm going to assume this is strings that starts with strings dot, was it has prefix comp1 T. It's T, right? Yep. So that returns a boolean. Cool. If that, then tcomps, need to do make with this. Tcomps comp1 equals true. Then exact same thing. Now comp2. So we have our tcomps. Now we need to do for, let's do tcomp in range tcomps. I'm just going to print out tcomp just so we can make sure all of this is working. And okay, I did the wrong format. Print. So let's run that and see if we're getting all the computers we should be. So there should be 1, 2. That looks correct. So we're going to be iterating over this, but we also need to record previous tcomps, and that will be equal to this. And it's to make sure the computer we're looking at, the ones that are connected to it, when we go through those ones, if there's a tcomp connection between 2 tcomps in a group, and we look at this one, it doesn't also look at this one again, so we know to skip it, because we don't want duplicates of it. So we do this, So we start off with tcomps tcomp equals true. Although I'm saying this, I need to So I'm just thinking there's a possibility of, let's say, T computer, then I look at A, and then I go through the connections, and it's connected to B. So then I've done checked through all the A ones. Okay, we've got a trio. Now I'm going to B, seeing all the connections, and now, but then that one's also connected to A. So I need to make sure I'm not repeating those as well. So then this would be for comp in range T comps T comp. Let's make sure I'm doing this correctly as well. Oh, wait, no, this should be connected. So let's see if I'm getting that all correct. I think so. Actually, let's do print of tcomp comp. So let's say you've got TC, so TC KH, TC WH. Okay, so that seems to all be working. Okay, I also need, I don't know, previous comp 2. So what we're looping over here is the second computer in the trio. So we've got computer 1, computer 2. We then need to do, even though I've called this comp, I'm going to call it for, actually we'll do previous comp 2, this equals true. Now we need to do for comp 3 in range, connected this, and if previous comp 2, comp 3, or previous t comps comp 3, continue. And I also need to do up here for this, if previous comp 2 comp, continue. So if we go past this, we're now at this state. We then need to do if connected comp 3 t comp output plus plus. So I think that should work. So let's run that. And we've got 7. So let's go here, whoop, run it on the test input, 882. Let's see if that is correct. Okay, answer too low. Okay, so not working. Let's go back to this input. Let's print line tcomp comp 3 and compare it to the actual. So let's just grab all this, paste it here. Oh, I'm getting 2. Okay, so let's just go get to breakpoint and look at what is inside connected. So we have connected. Let's find a TA. So TA has CO and DE. It has CO and KA, and has DE and KA. So that works. So now it's fine. Okay, we've got TC here. TCWH. That's the only one for TC. TD. QPWH. Okay, what if I get rid of these? Oh, actually, I did the wrong condition. That should be this. That should be that. And then, I think this works. Oh, I don't know. I guess I just need to run it. Okay, we're getting 6 now. So we've got, or actually, we need to do, if it was a T comp, then we've already done everything for it. Or, previous comp 2, 3, and, okay, let's take a look at it again. Okay, okay, the way I've done it is not working. Let's change how it works. What we should do is a list with 3 items of the strings, and we order them based on, well, I guess the alphabetical order of each item. And we are, instead of, okay, yeah, that's what we're doing. That would make things easier. Previous combo, this would be map string 3 bool. Don't need these anymore. And we will do string, current combo is equal to this. Nope, I need to do, so make this and 3. So for this, current combo 0 is equal to tcomp. We then do current combo 1 is equal to comp, and we get rid of all of that. And then in here we do current combo 2 is equal to comp 3. Then we do, I'm going to assume there's a strings format order for this. So let's say strings dot order. Oh, sort. That's not what I was expecting. Is there like a built-in sort maybe? Oh, sort strings. Okay, cool, that works. Current combo. Okay, I don't need to return it. Now we do if not current combo. Okay, what's going on with you? Can't use current combo variable. Okay, I guess I don't need to do what I did there. Just this was fine. What's wrong with you? Can't use current. Why doesn't that work? Oh, okay, sure. We'll change that to this, and we will Okay, so up here we'll just do... Can you still do numbered while it's like that? Maybe, who knows, we'll find out, yes? Okay, so do this, we do plus plus, then do previous combo, current combo equals true, and you are unhappy. Okay, what do I need to do to make you work? I guess I can just turn it into a string. So we've got this, and we just do string. I should do this, and I assume we'll just combine them all into a string, no? Fine. Combo is equal to current combo 0 plus, and we're just going to do this, 1 plus 2. Hopefully that makes it happy now. So we do that. Now let's run it. Okay, I thought that would happen. I need to do initialize it with just some fake values like this. Now that should work. 52. Okay, so this is not working at all. Okay, I guess I should check to see if it's actually sorting, because I thought it would, but... Oh, actually, if I sort it, these computers may no longer be in the correct spot. So I need to be creating a new list. So sorted combo, make that equal to list string, and then do this inside of it. So 1, 2, 3, and then we do sorted combo with it. Now hopefully that's what was needed. Okay, still 52 is not working. Let's go through and figure out. So current combo TCCOKA. We create this. We have sorted combo. So that should be COKATC, and that is. We now have the combined string. If it's not that, good, that's working. Alright, I'm not even I removed the check for if all three are actually connected. That's the problem. So if not connected, comp3, tcomp, continue. Now it should work, hopefully. There we go, 7. Now if we switch to this one, it should be greater than, it was like 880. That's greater than 880, so hopefully that is correct. And it was correct, so now on to part 2. There are still way too many results to go through them all. You have to find the LAN party another way and go there yourself. Since it doesn't seem like any employees are around, you figure they must all be at the LAN party. If that's true, the LAN party will be the largest set of computers that are all connected to each other. That is, for each computer at the LAN party, that computer will have a connection to every other computer at the LAN party. In the above example, the largest set of computers that are all connected to each other is made up of CODEKATA. Each computer in the set has a connection to every other computer in the set. The LAN party posters that the password to get into the LAN party is the name of every computer at the LAN party, sorted alphabetically, then joined together with commas. The people running the LAN party are clearly a bunch of nerds. In this example, the password would be CODEKA, What is the password? Okay, that works. So we copy all this, put it into part 1 here, and okay, I've kind of confused myself a little bit because what I'm doing here just doesn't do anything. So I guess we need to slow down a little bit, probably think it over. Let's have a list containing all the computers. We then check to see if all the computers in this list are connected to each other. We will create a function, so is LAN. This will be a function which takes in, call it a group, and this is a list of strings, and it returns a bool. We will do, for I equals 0, I is less than length of group, I plus plus. For j is equal to I plus 1. J is less than length of group, j plus plus. We will return true here, and then we do if not connected ij, return false. So we're going to use this throughout. We are going to try most combinations of this. Okay, what's wrong with you? Oh yeah, group. That's what we need to do first. So we're going to try just create the list and see if it's valid or not. So I think we can get rid of this. Let's bring this down to here. So we've got isLAN. Bring this to here. Let's change this. Let's do largest group. This will be final outcome. When we're working through it. Actually, we don't need to set anything there yet. No, we do. When we run through this, we're going to be figuring out what's going on. And let's just go to here for now. Output is equal to this. No, string dot join, and it'll be this, then output. So we don't need that here. We will need to sort things at some point, but I'm not sure when. So we'll still do our queue, and we will do. So first we'll iterate over this. So okay, current group is equal to. No, we need multiple possible queues at the same time, because there's multiple possible groupings of computers that we could have at the exact same time. That's one of the problems I was having. So we first start off with just this one single one. The current group we're looking at is basically what we were doing here. So current group, there we go. Now we will check to see if this is a LAN. If is LAN, current group. If it's not, we can get rid of it and not look at it again. So if you are a LAN, and if the length of current group is greater than the length of largest group, you are equal to current group. So we've got that logic down finally. So within this group, the numbers are added in a certain order. If you are currently a LAN, we want to look at the last added computer and check to see if any of its neighbors are also connected to the other computers in it. Okay, actually, so that comes with the is LAN part. We need to see if there are any other computers which aren't currently in the queue. So for, and let's delete all this, because that was just confusing me. So for neighbor in range connected, and this will be current group, and it will be length of current group -1. So going through every single neighbor it has is in group. Actually, we'll change that to is not in group equal to true. For C in range current group, if C is equal to neighbor is not need to go on is non-group equals false, break. Then we need to do if is not in group, then we need to add this current neighbor to the queue. So then it'll be we'll create a new group. So it'll equal append current groups. No, that will equal a brand new string, and then current group dot spread it. Oop. Then we do new group. No, it's not what I want. New group equals append neighbor. Now queue equals append new group. So we start off with one single computer. We look through all of its neighbors. Are you currently in the group? If not, we are going to create a new queue with you. And initially, it's going to be all of them. We then check to see if they are all connected with this LAN. Are you connected? Yes, you are. So we'll continue. Now, with this brand new computer added, we check to see all of its neighbors, or the ones it's connected to. Part of that we'll find the first computer added, and then we'll skip that. But all the other ones which aren't connected get added. We then do is LAN. We check to see if this brand new one is also connected to the others. Okay, I think we finally got it. Although only we can find out is by running it. And where are you at? Error current combo. Okay, that's fine. I need to sort.strings you first. That's right. Now we run you. Oh, that is looking correct. Code de kata. Yep, that is correct. Oh, took me a while, but I think we finally got it. I was just getting confused about the whole looking over all of the computers, having to compare them, creating the queues. Like, that just wasn't going through my head properly. Okay, so that was taking too long. I need to do some caching, I'm pretty sure. So we'll go to, yep, cache, and we'll just do make map string. And what we can do here, no, it's when we're trying to add it. If is not in group, new group. So we've got new group. Let's do new sort strings new group, and then we can do if not cache new group. We then do this. Actually, let's do string group, and you can be strings dot join. Don't need to join you on comma for this. We just need to be able to cache you. That'll be equal to true, and then we add you. It would go through every single one and every single one over and over again. But let's verify if it's working still with this. So it's like code de kata something. Okay, why don't you work? Not enough arguments. Okay, fair enough. Okay, so that's working. Now hopefully when we switch back to this, it will not take forever to run. There we go. I had it running for a few minutes before, and now that just took a second. So let's put that in, hope that it actually works, and submit. There we go. That is day 23 completed. So, if you like this video, make sure to like and subscribe.